Good morning, students. Myself, Janish Shah, Assistant Professor at LJ College of Engineering and Technology. Today, we are going to learn further about the stack operations. In our previous lecture, we studied about the stack operations on stack and how we can write algorithm, how we take the array indexes. Okay, I'm just repeating in 2 minutes. Students, please take a note and pen. Please write down that here in our lectures, in algorithms, we are taking array index starts from 1. But in programs, we took array index starts from 0. Okay, fine. Because we are taking a reference book as Tremblay and Sorensen. Okay, so for each and every algorithm, I refer Tremblay and Sorensen as my reference book, and it is already written in your syllabus. Okay, so please make a note that array indexes starts from 1. Fine. So what we had seen in push operation, that in push operation, what you need to do for any insertion operation, we need to check the overflow condition. So in push operation, you need to check first the overflow condition, that is top greater than equal to n. Okay. The next is to increment the top pointer, that will become top arrow top plus 1, and the next one is to insert the value. So here we have seen that to insert each and every element in stack, what we need to do, the first step is to increment the top pointer, then to insert that element x at the position top, that will become s of top is arrow x. Then the next statement is to return something. It will becomes, we are not here to return something, that's why the return type of the algorithm is procedure. Okay, so now students, let's start with the C function of push algorithm. Stack is full. So the first one is the C function of push algorithm. The function and algorithm both are most probably working in similar way. Okay, so what was your algorithm name? That is push. How many arguments you took, like s, top, n, and x? Okay, and what is the return type is? Nothing. Procedure means does not returning anything, that's why the return type is void. So the function is integer s of 5. I am taking a variable integer s of 5 that represents my stack. Top pointer variable x element need to be inserted, then n and size of the array. Students, I am again saying that here in function the array index starts from 0, but in algorithm array index starts from 1. Okay, so the first is assume that integer array s, top, and n, all three variables are declared as the global variables. Okay, so the global variables, we should not take them as argument. So here we have the stack. So the stack, I'm taking the same example as previous. Okay, so what will be the function definition is void push. Void push. So why are you not taking x as an argument? If you are taking x as an argument, then you should pass it at the function calling time. Okay, we will see this in our practical sessions. Okay, but just today I'm just giving you a small little bit information about the C function of push, declaring a variable integer x. Okay, now remember the first condition. First condition is that if top is greater than equal to n, top is greater than equal to n, but at that time the array index starts from 1. Here array index starts from 0, so that the condition will become top is greater than equal to n minus 1. Then printf stack is full. Stack is full. Else printf enter an element. What I need, if stack is full, should I need to enter something? No. But if stack is empty or any places are there to insert an element, then what I should do, I need to ask to enter an element. Okay, so printf enter an element, scanf ampersand that element. Okay, so here the element is x. So what I need to write is scanf percentage t ampersand x. Okay, so the next position is top plus plus. Top plus plus, that means the first step is to check the overflow condition that will be written in the if. Next is to insert something, we need x. I did not take x as an argument, so I need to ask it from the user. So enter element x, scanf x. Now second step number 2 is increment top pointer. Okay, increment top pointer, that means top plus plus. Okay, so next is to assign x value to at the top index. Assign x value at top index, that will become s of top is equal to x. Fine. So this is are the C function for the push. First is check the overflow condition. Then the second step is to see get the value from the user. Okay. And the next step is to increment the top pointer. Another last one is a s of top is equal to x. Students, do we return something over here? No. That's why return type is void. Fine. Okay. Let's take another algorithm, that is pop. So what do you mean by the pop? Pop means returning something, deleting something from the stack. So here, if you are returning something in algorithm, what you need to do is to take function as a return type. Okay, so the here we write function, not procedure. If your function or algorithm is not returning something, then you need to write as procedure. If algorithm returning something, then it's known as function. Function name is pop. Okay, now what we need is s comma top. S comma top. Okay, s represent stack. X is inserted element on the top of the stack. But do we need x over here? No. Okay, next is top. Top is a pointer at pointing to the topmost element of the stack. Okay, fine. So here I am taking one stack. See, in this figure, what I did, that I taking one stack as here top is pointing to the 30th element. It is situated at third position. Okay, fine. Now if I want to do pop operation, then what happen? Top will be decremented. See, in push operation top is incremented, in pop operation top is decremented. If I want to insert something, then I should increment top pointer. If I want to delete something, then top is automatically decremented. Fine. Then what happen? If I am going doing a pop operation, then 30 will become removed from the stack. Top is situated at 2. Again pop, 20 will become removed from the stack. Top is situated at 1. Again pop, 10 is removed from the stack. Top is down. 1 up before 1. What will be the index of stack is 0. So our condition is if top is pointing to 0, then stack is underflow. See, in push we check overflow, in pop we check for the underflow. What do you mean by the underflow? Underflow means below that you will not able to find any element because stack is empty. So whenever you are not able to find an element, that condition is known as underflow. Fine. So if top pointing to the 0, see over here, top pointing to the 0, then the stack is underflow. That will become my first condition. See, in algorithm, if top is equal to 0, then stack is underflow. But in program, index starts from 0. So what we are doing, we just minus 1. So that means if top pointing to minus 1 in program, then the stack is underflow. But in algorithm, if top pointing to 0, the stack is underflow. Now, what will become my second step? I just need to decrement the top pointer. So, and after that, return s of top plus 1. S of top plus 1. How will this step will be executed? Let's see this in this figure. The first step is to decrement this top pointer from 30 to 20. Okay, from 30 to 20. And then top pointing to this position. What I need to do is to remove 30. To remove 30. See, What is s of top? S of top is 20. S of top is 20. What is top? Top is at 2. S of top 20. Top is an index. S of top shows value. Again, top shows the index. S of top shows value. The top is at situated at 2. S of top value is 20. Now, what I need to remove is 30. What I need to remove is 30. So I need to return s of top plus. Fine. So I'll get 30 in return answer. Okay. The next step is 30 is gone. Top is here. Again, I want to do the pop operation over here. Then 20 is gone. 10 is here. Fine. Again, I'm doing pop operation. 10 is gone and top is situated at 0. See, the stack is empty. Stack is empty. In empty stack, top is pointing to 0. Fine. So let's begin with a program. Here, say function, taking these examples, the thing is that the first, same like as push operation, s of 5, array represents stack, top pointer to the variable, and size of the stack, assume array s, top, and n all are globally declared. So here I am returning something, that's why taking integer. Okay, integer pop, declaring integer y. The first condition is check the stack is underflow or not. This figure shows about the algorithms. In algorithm, top pointing to 0, then it is underflow. But in program, if top pointing to -1, then its stack is empty. Return -1. Else, what I need to do? Decrement top pointer. That's why I need to write top minus minus and then return this value. So I'm just storing the value in y. Y is equal to s of top plus 1 and return y. Function is completed. Okay, so what I did is first declare a variable y, integer top is equal to -1, checking the condition. If the top is equal to -1, then stack is underflow, then return -1. See, here you can write return 99, return 100, anything, because it's integer, returning integer value. Okay, else top minus minus, I'm storing y is equal to s of top plus 1. Sir, if I'm not taking y over here and just directly write return s of top plus 1, is that fine? Yes, it's fine. It is not necessary to take y variable. Okay, now moving forward to the next topic is peep operation. Students, peep means fetch ith element from top of the stack. Fetch ith element from top of the stack. Now, what do you mean by the ith element? Let me clear. The first one is peep, fetching something from top of the stack. Fetching something from top of the stack. Which element? Top ith element. Okay, from top ith element. Okay, so I am taking argument as s, top, and I. Okay, see here. The first you need to do to check the underflow condition. How? See, if this is a stack, this is a stack, please understand it carefully. This is a stack, then what happens if I want to ask you that fetch second element from top of the stack, fetch second element from top of the stack, then I becomes 2. I becomes 2. Okay. So what will be the second element? This is the first element from top of the stack is 30. Second element from top of the stack is 20. Okay, the 20 is become my returning value. Okay, fine. Again, I am asking you to fetch fourth element from top of the stack. Fourth, see, 1, 2, 3, and 4. Again, 1, 2, 3, and 4. Is there any element at fourth position? No, that means underflow. That means underflow. So what will be the condition for the underflow is if top minus I plus 1 is less than or equal to 0. How? How? Let me clear. See this. Here, the top is situated at 3. Top is situated at 3. And if I want to fetch fourth element from top of the stack, then I becomes 4. I becomes 4. Now, top value is 3. Top value is 3. I is 4. Top minus 3 minus 4 is 3 minus 4 is minus 1. Is there any element minus 1? But what will become my fourth element is 3. 2, 1, 0. What I get? Minus 1. So I need to add one more. Plus 1 is equal to 0. Is there an element at 0? No. That's why the stack is underflow. Okay. So now you can you easily understand it? Okay. So if is there an element at this position, I just need to return that value. Okay. Return as of top minus I plus 1. See again this when I is equal to 2. If I want to fetch second element from top of the stack, second element from top of the stack, okay, what is the top value is 30, second element from the top of the stack is my 20. Now again put in this formula, top is top is 3, okay, I is 2, okay, plus 1, so 3 minus 2 plus 1, the index value is 2, index value is 2, index at 2, which element situated at this index? It is 20. Fine. So what I got? 20. That will become my right answer. So that is return as of top minus I plus 1. Again, student, top shows index, as of top shows value. Top shows index, as of top shows value. So here top minus I plus 1 shows index, but as of top minus I plus 1 shows value. Clear? Now, next is change. Okay, sorry. The C function for Peep. It's very simple, same as pop. As of 5, top, n, and I all are declared. Taking an example, integer Peep, integer I. See, here I already, if I do not need to write I over here, I do not need to write I over here. If as I do not want to take I over here in my parent parameters, that's why I'm taking I inside the function block. Okay, so integer I, printf, which element you want to fetch. Okay, scanf that I value, then check the condition. The first is underflow condition is if top minus I plus 1 is less than or equal to 0. Less than or equal to 0 is in algorithm. Okay, but in program we are taking minus 1 because in program index starts from 0. So minus 1, no element is there, return minus 1. Next one is else, return as of top minus I plus 1. Isn't it easy? First you need to check the underflow condition, then returning that element. Okay, so the next topic is change. Okay, so let's start with the change. Change means change ith element from top of the stack. Same as Peep, same as Peep. In Peep, what we did, we fetch out ith element from top of the stack. Okay, if this is a top, okay, 3, 2, 1. Okay, this is stack is completed. 3, 2, 1. Stack is completed. Now, is there any element at zeroth position? No. Okay, so I need to change third element, second element, first element, fourth element, or ith element from top of the stack. Fine. So let's begin. Here, the change is a procedure because we did not fetch anything. So I should not return any value in the change algorithm. Okay, fine. That's why it's a procedure. And when the change is procedure, it does not returning anything. Fine. Then here we need 4 arguments: s, top, I, and x. S shows stack, top shows a pointer, topmost pointer. I, that means index from which we need to access the element or change the element, and x is a new value which is going to be inserted at that position. Fine. So see this, if this is a stack, if this is a stack, then top pointing to the third position. If I want to ask to change fifth value from top of the stack, fifth value from top of the stack, then 3, 2, 1, 3, 2, 1, and 0 and minus 1. Is there an element at minus 1? No. That means it returning false. If I want to ask to change the fourth value, then top 3 minus I 4 plus 1 becomes 0. Is there any element at zeroth index? Yes or no? No. That means I should not change the value. It means check, the first condition is check for the underflow. Check for the underflow of the stack. The condition becomes top minus I plus 1 is less than or equal to 0. Is less than or equal to 0. Then write stack underflow and change algorithm. Take proper action on it. And now the next, what I need to do, I need to change the second element. See, I need to change the second element from top of the stack. That means I becomes 2. I becomes 2. That's why here x value is 80. Just put it down. Top minus I plus 1, 3 minus 2 plus 1. The answer is 2. See the index 2, 20 is there. Okay, it's a second index from top of the stack. This is the first index from top. This is the second index from top. So I need to change 80. So what I need to do, just take variable x at this position. Okay, fine. Is that clear? I just need to put the 80 at this top minus I plus 1 position. Students, if top is the index, top shows index, top shows index at same time as of top shows value. Okay, if top shows index at sub top shows value, same like that, top minus I plus 1 shows index of the array, and as of top minus I plus 1 shows value. Clear? So what I need to do, change the ith element from top of the stack. I just need to assign s x at position top minus I plus 1. So I am just assigning x at top minus I plus 1 position for stack s. Fine. Isn't it easy? So let's move forward to the C function of change algorithm. Students, if you have seen here, in algorithm, we have written procedure. That means what we just need void. Do not need any integer. Fine, because algorithm returning nothing. Procedure means does not return anything. That's why change algorithm or change function does not return anything. It is very much easy to write like void in the place of procedure, change. There are four arguments are there as top, x and I, but as top both are global. Fine. X I am passing in the as a variable and I am taking inside the function. Remember my lecture of function, second introductory lecture. What I told you that in C, if we need to pass the variable, if we need to pass the variable as an argument, we should not ask them inside the function. But if we did not pass variable as an argument, we need to do printf scanf inside the function. So integer I, printf, which element you want to exchange, scanf that index. Now, if top minus I plus 1 is less than or equal to minus 1, why it's minus 1? Because in program, we take array index starts from 0, but in algorithm, we take array index starts from 1. Okay, that's why the condition becomes in the place of 0, we are writing minus 1. Then no element to change. If is there an element to change, then else s of top minus I plus 1 is equal to xc. Here I am writing is equal to in the place of arrow. Okay, because arrow is assignment. Same like that, arrow is assignment in algorithm and is equal to assignment operator in functions, C programming language. Fine. So what happened? The x will be changed. If the x is 80, then it will be changed at second number position. Okay. So students, till today, we learn about the different operations on stack: push, pop, peep and change. In push we are inserting something at top of the stack. At pop, in pop we are removing from top of the stack. In push, top is incremented. In pop, top is decremented. Okay. In peep and change means fetch. Peep means fetch ith value from top of the stack. Ith value from top of the stack. That's why you need to write underflow condition over there. Okay. And in change, again it change ith element from top of the stack. That's why also again you need to check the underflow condition. Okay. So if you have any doubt in this chapter till stack operations, then please feel free to ask me. Till that, keep learning. Thank you so much.